The moon, a timeless wonder of the night sky. It's not just a beautiful sight, but also an essential part of life on Earth. For millennia, humans have gazed up at the moon, contemplating its mysteries. Ancient civilizations told myths about it, poets have drawn inspiration from it, and scientists have dedicated their careers to understanding it. Have you ever wondered why the moon is so big, how it got there, or why it can perfectly block out the sun during a solar eclipse? Let's explore the science and the marvel of our closest celestial neighbor. All right, let's start with the basics. Why is the moon so big? Compared to the moons of other planets in our solar system, Earth's moon is unusually large. It's about 1/4 the diameter of Earth itself. Think about that for a second. That's like saying if Earth was the size of a basketball, the moon would be about the size of a softball. Most moons in our solar system are tiny compared to their parent planets, more like little pebbles orbiting giants. So, what makes our moon so special? Scientists believe the answer lies in a cataclysmic event that happened billions of years ago, a cosmic collision of epic proportions. Picture this, the early solar system, a chaotic and violent place. Planets are still forming, asteroids are zipping around like bumper cars, and then, wham! A Mars-sized object named Theia slams into the young Earth. The energy released from this impact was unimaginable, enough to melt rock and vaporize oceans. Debris from both Earth and Theia was blasted out into space, forming a massive ring around our planet. Over millions of years, this debris, bound by gravity, slowly clumped together, forming our moon. The moon we see shining in the night sky is essentially the product of a cosmic car crash. This giant impact theory is supported by evidence, from the moon's composition to its orbit. For example, the moon's rocks have a remarkably similar composition to Earth's rocks, suggesting a shared origin. You know, people sometimes take the moon for granted. They see it up there, night after night, and they think, oh, that's nice. But the moon is more than just a pretty face in the night sky. It's not just some celestial nightlight, it's a powerful force that has shaped our planet and life itself in profound ways. Let's start with the tides. Everyone knows the moon controls the tides, right? But how does it do that? It all comes down to gravity. The moon's gravitational pull is strongest on the side of Earth that's facing it. This pull creates a bulge of water on that side of Earth. Since Earth is rotating, there's another bulge on the opposite side. These bulges are what we experience as high tides. As Earth rotates, the areas between the bulges experience low tides. It's like a cosmic dance between Earth and the moon, with gravity as the music. These tides have played a crucial role in the development of life on Earth. Billions of years ago, life began in the oceans. The tides, driven by the moon's gravity, created a constantly changing environment along coastlines. This intertidal zone became a crucible for life, a place where organisms had to adapt to survive the harsh conditions. And adapt they did, eventually giving rise to the incredible diversity of life we see in our oceans today. Now let's talk about one of the most awe-inspiring celestial events, a total solar eclipse. The day turns to night, the temperature drops, and for a few precious moments the sun is completely blocked out by the moon, leaving just a fiery ring around the edges. It's a sight that makes you feel small, connected to something much larger than yourself. How is this even possible? How can the moon, which is so much smaller than the sun, perfectly cover it up like that? It's all about perspective and some cosmic geometry. The sun is about 400 times farther away from Earth than the moon. But it's also about 400 times larger than the moon. This remarkable coincidence means that when viewed from Earth, the sun and the moon appear to be almost exactly the same size in the sky. Isn't that incredible? It's like the universe set it up that way, just for us to enjoy the show. The moon is slowly drifting away from Earth at a rate of about 1.5 inches per year. In a few 100 million years, the moon will be too far away to perfectly cover the sun during eclipses. Future generations will see annular eclipses, where a ring of sunlight encircles the moon, but the truly spectacular total eclipses will be a thing of the past. So if you ever get the chance to see a total solar eclipse, don't miss it. Chapter 4, a dynamic duo, the moon's changing relationship with Earth. The moon we see today, with its craters and Maria, those dark flat areas, wasn't always that way. It has a story to tell, a story written in rock and dust over billions of years. The moon has been Earth's constant companion for eons, but their relationship has been anything but static. The moon's surface, pockmarked with craters of all sizes, is a testament to the violent history of our solar system. Each crater is a scar left behind by an asteroid or comet impact. Some of these impacts were so powerful that they created massive basins, hundreds of kilometers across. These basins were later filled with lava that welled up from the moon's interior, forming the dark Maria we see today. The moon's story isn't just about collisions and craters, it's also about volcanic activity. Billions of years ago, the moon was a much more geologically active place than it is today. Volcanoes erupted across its surface, spewing out lava that flowed for hundreds of kilometers, creating vast plains and intricate channel systems. Over time, this volcanic activity waned, leaving behind the dormant landscapes we see today. The moon is moving away from us at a rate of about 1.5 inches per year. That might not seem like much, but over billions of years it adds up. The moon used to be much closer to Earth than it is today. Billions of years ago, a day on Earth was only about 6 hours long. This gradual drift away from Earth also means that the moon is getting smaller in our night sky, at least from our perspective. Don't worry though, it'll still be around for billions of years to come. Chapter 5: The Moon, a Muse for Humanity. The moon isn't just a celestial object, it's a source of endless fascination. It's a celestial canvas upon which humanity has projected its dreams, fears, and aspirations for millennia. Long before we ever sent a spacecraft to the moon, it captivated our imaginations, inspiring countless myths, legends, and works of art. Ancient civilizations, from the Egyptians to the Mayans, developed intricate lunar calendars based on the moon's cycles. They recognized the moon's influence on the tides and used its predictable phases to track time and mark important events. The moon became intertwined with their cultures, influencing everything from agriculture to religious practices. The moon's influence extends far beyond ancient civilizations. It's been a constant source of inspiration for artists, poets, and musicians throughout history. Think of Debussy's Clair de Lune or Van Gogh's Starry Night. The moon's enigmatic presence has sparked the imaginations of creative minds for centuries, leading to some of the most enduring works of art in human history. The Apollo missions didn't just land humans on the moon, they ignited a spark of wonder in the hearts of millions, inspiring generations to dream bigger and reach further than ever before. Even today, the moon continues to inspire us. Chapter 6: Destination Moon, the future of lunar exploration. We've explored the moon's past, from its fiery birth to its role in shaping life on Earth. We've marveled at its beauty and its influence on human culture. But what about the future? What role will the moon play in humanity's destiny among the stars? The moon is no longer just a distant object of wonder, it's becoming a destination, a stepping stone to further exploration of our solar system and beyond. NASA's Artemis program aims to establish a sustainable presence on the moon by the end of this decade. We're talking about building a base on the moon, a lunar outpost where astronauts can live and work for extended periods. The moon offers a unique proving ground for developing the technologies and strategies needed for deep space missions. It's relatively close to Earth, just a 3-day trip, which makes it easier to provide support and resupply. Scientists believe that water ice exists in permanently shadowed craters at the moon's poles. This water ice could be a game changer for space exploration. We could potentially extract water for drinking, for growing food, and even for splitting into hydrogen and oxygen to create rocket fuel. Imagine that, a lunar gas station for missions to Mars and beyond. E outro, keep reaching for the stars. The moon is more than just a rock in the sky. It's a partner to Earth, a stabilizer of life and a source of endless fascination. It's a celestial time capsule preserving the history of our solar system and a beacon guiding us towards a future among the stars. Whether it's pulling the tides, lighting up the night, or inspiring our next great adventure, the moon reminds us of our connection to the cosmos. Thanks for joining me on this lunar journey. If you enjoyed exploring the wonders of the moon, give this video a thumbs up, subscribe, and let me know in the comments what you'd like to explore next. Until next time, keep reaching for the stars.